Beneath the serene beauty of America's oldest national park lies a hidden, sleeping monster. Millions of tourists visit each year, completely unaware of the ticking time bomb below. Geysers erupt and hot springs boil, hinting at the unimaginable power locked away deep underground. If this subterranean giant wakes up, the United States will fundamentally change forever in an instant. The question is not if it will happen, but exactly when the countdown reaches zero. A supervolcano can unleash an eruption of magnitude 8 on the explosivity index. Such an event possesses the raw power to wipe out entire regions and alter the global climate. To understand this existential threat, we must look at the deep history of this volatile hotspot. We unveil the world's greatest mysteries. Welcome to Yellowstone, a massive volcanic caldera stretching across Wyoming, Montana, and Idaho. Beneath this landscape lies a stationary mantle plume, radiating extreme heat directly from the Earth's core. The North American tectonic plate slowly drifts southwest over this hotspot at nearly 2 inches every year. This agonizingly slow drift over the mantle plume has carved a devastating track of massive volcanic scars. $2.1 million years ago, the Huckleberry Ridge eruption ejected 2,400 cubic kilometers of debris. This single geological event buried half of the North American continent under thick layers of toxic ash. 1.3 million years ago, the Mesa Falls explosion struck, radically reshaping the regional bedrock. Then, exactly 640,000 years ago, the Lava Creek super-eruption fundamentally changed our planet. It blew 1,000 cubic kilometers of shattered crust into the stratosphere, leaving a massive subterranean void. The surface ground collapsed into itself, forming the exact geographic basin that millions walk upon today. However, geological core samples confirm that the thermodynamic engine driving this cycle has never actually stopped. Basaltic magma continuously rises from the lower mantle, pooling and melting the solid crust directly above it. This constant subterranean thermal friction brings us to the present day, where scientists maintain strict vigilance. Every microscopic shift in the bedrock is now recorded, calculating the exact timeline of the next rupture. To achieve this, the United States Geological Survey operates an advanced network of continuous GPS stations. Satellites utilizing InSAR radar technology scan the caldera from orbit, detecting millimeter-level ground deformation. The data reveals that certain areas of the park have rapidly pushed upward by several inches. This sudden ground inflation frequently correlates with the extreme pressurization of hydrothermal fluids, or magma chambers, deep below. Simultaneously, seismographs detect thousands of micro-earthquakes every year, mapping the invisible fault lines deep below. These specialized instruments measure ground tilt with microradian precision, flagging the slightest subterranean displacement. They discovered that the volcanic system is not a single pool, but two interconnected, massive reservoirs.
These concentrated seismic swarms often indicate the violent movement of magma breaking through solid rock layers.
The upper magma chamber alone holds enough liquid volume to fill the entire Grand Canyon. Even more terrifying, the deeper mantle reservoir is over 4 times larger than the upper chamber. Together, these chambers act as a colossal pressure cooker, slowly accumulating extreme heat and volatile elements.
Researchers now focus intensely on the chemical composition, searching for the ultimate eruption trigger.
If the molten rock absorbs too much dissolved gas, specifically carbon dioxide and water vapor, pressure spikes. Geologists continuously sample hydrothermal vents, measuring escaping helium-3 isotopes to track this subterranean volatile buildup. A sudden, massive spike in these toxic gas emissions would signal that fresh magma is ascending fast. Coupled with a sudden swarm of high-magnitude deep earthquakes, the warning signs would become undeniable.
To understand how this sequence ends, scientists use supercomputers to run complex rock fracture simulations.
These models calculate the exact thermal stress required to shatter the solid bedrock containing the magma. Day and night, the tension builds as automated systems track the real-time data against critical thresholds. Every thermal anomaly and seismic pulse is evaluated to predict the exact moment of catastrophic failure.
This technological net stands as humanity's only early warning system against an unstoppable planetary force.
But the ultimate question remains. What does the data tell us about the actual eruption sequence? When the bedrock finally shatters, the sudden depressurization triggers an immediate, apocalyptic supersonic blast. Hard seismic data from the deep crustal arrays confirms the exact velocity of the ascending pressure wave. Core samples extracted from deep boreholes reveal historical mineral fractures matching current stress projections. Satellite interferometry confirms millimeter-scale ground deformation, proving the chamber beneath is actively swelling. Mass spectrometry of thermal emissions verifies a steep upward trend in mantle-derived gas ratios. When every data point aligns, the countdown reaches its ultimate conclusion and the final warning is sealed. Geochemists also analyze the toxic gases venting from surface fumaroles, searching for sudden spikes in deep Earth helium isotopes. A sudden, drastic change in gas composition acts as an early warning signature of fresh magma rising rapidly toward the surface.
If this delicate subterranean balance were to catastrophically fail, the sequence of events would be horrifyingly rapid.
Massive, violent earthquakes would instantly shatter the region, as immense geological pressure shatters the overlying bedrock.
A colossal column of superheated ash, pulverized rock, and toxic gas would erupt upward, punching directly into the stratosphere.
Superheated pyroclastic flows, reaching temperatures of over 1,000 degrees, would race down the mountainsides at hurricane speeds, incinerating absolutely everything in their path. Within hours, a heavy, suffocating blanket of volcanic ash would spread outward, completely burying thousands of square miles across North America. This immense volume of airborne particulate matter would physically block incoming solar radiation, plunging the northern hemisphere into a prolonged volcanic winter. Global agriculture would face catastrophic failure, leading to worldwide food shortages and the collapse of fragile ecosystems. The economic and social infrastructure of modern civilization would be strained beyond its absolute breaking point, fundamentally altering the course of human history.
However, despite the immense, terrifying power slumbering beneath our feet, an immediate eruption remains highly improbable.
Ultimately, Yellowstone remains one of Earth's greatest natural wonders, a breathtaking reminder of the raw, untamed forces that shaped our planet. Subscribe to join the journey. Leave a like and share your thoughts below.